Welcome to a follow-up video on comparing agentic frameworks, where I'm going to be comparing LlamaIndex Workflows, PydanticAI Agents, and SmolAgents. I'm going to be reviewing how suitable are they for production systems, and also which applications do they work best in, as each of these frameworks has key advantages in different scenarios. I'm going to be using the same format as last time to compare them, but first let's take a look at their GitHub repositories and how well they've been doing. These are the other three frameworks I compared last time: AutoGen, CrewAI, and LangGraph, and they were all released at a similar time last year, took off quickly, and then have been growing steadily since. These other frameworks are much more recent, and they've had a very sharp spike in their uptake. I don't have a reliable number for LlamaIndex Workflows, unfortunately, because they don't have a dedicated repo for their workflows code. So how are we going to be comparing the three frameworks? I'm going to be using a radar chart and scoring them against 6 key metrics. How fast are they to learn? Other more soft features like documentation. The other features I'm going to be analysing are: do they support streaming, human-in-the-loop execution, time travel debugging, can you go back in time, change something and see what would have happened? Do they support memory, low-code development, and which languages do they support? So let's get stuck in first with SmolAgents. So how does SmolAgents from HuggingFace work? In SmolAgents, all agents are React agents. And if you're not familiar what a React agent is, it's a design pattern for agents that's backed by research, and most popular frameworks use React agents as their building block. The way it works is you've got a language model that chooses to use particular tools like web or code execution, and the outputs are then fed back into the language model, which can decide either to end there and provide the answer to the user or call another tool. They're really fast to get up and running in SmolAgents. With a single line of code, you can create your agent and provide it with tools, similar in a way to other frameworks like CrewAI. In SmolAgents, there are 3 types of agents. You've got code agents, where the way it provides the information about which tools should be executed is in code. SmolAgents reference research to show that this strategy is more effective than typical tool agents where the outputs are written in JSON. It also provides extra flexibility that we'll see in the next slide. The third type of agent is manager agents, which is their way of implementing a multi-agent system, which we'll also see in a few slides. So, code agents, what's that all about? The advantage of code agents is a few things. Because the tools are written as code, you can combine the outputs of multiple tool calls, and you can also handle failures significantly more easily. The code written will have access to other libraries that you can use to do more interesting things off the back of those tool calls. The problem with it is that it is a massive security vulnerability if you're executing the code on your server, which means you need to have a sandbox environment either in the cloud or on your server where you can safely execute this code. So it comes with pros and cons, but I can see this being particularly useful for open source models which don't have support for structured output. And so it allows you to use any HuggingFace model to build your language model agent. How do their managed agents work? You can create multi-agent systems, and here's an example for web research. In SmolAgents, they use a hierarchical pattern for their managed agents, but their manager agents are also React agents. And here's the way it would work. If you had a question to answer, such as estimate the number of software engineers that will be needed in 5 years' time based on historical trends, the manager agent would then decide, can it answer this question on its own with its tools, or does it need to ask one of its child agents a question to be able to answer this? So it can ask a question to this web search agent, which can use its web search tools to come up with some research. This agent can return its response to the manager agent, who can then combine that information with code execution or any other tools it needs to use to provide the final answer to the user. I quite like this pattern, and I haven't seen it before in this type of framework where you're highly constrained to the types of agents you can create. Now let's get stuck into reviewing SmolAgents. Starting with learning curve. SmolAgents claims to be the simplest framework out there to build powerful agents, and it looks like it is definitely one of them. If I go into the guided tools section, I can see a quick example of how to build a code agent, and this is using an API model from HuggingFace. You can then create your agent immediately and run it straight away, and this is the same for all of their types of agents. There's not a huge amount of documentation. There's only 3 different types of agent that you can build: your code agent, tool agent, and your managed agent. I've probably only been looking at HuggingFace API for about an hour, and I think I understand just about everything possible that you can do with it. So for learning curve, I'm going to be giving it a 10. Next up is integrations. I think it's done a pretty good job here. We saw before that you can integrate with any model easily enough. You can also integrate with OpenTelemetry, which is an open source alternative to Langsmith for being able to visualize your runs, so you can see and debug exactly what's happened, and I think this is really important. And so I'm glad that HuggingFace has gone open source. It's got good integrations for its tools, so you can use LangChain style tools, which is really important because I've seen that's what most people are doing. What else I think is really interesting is that you can use HuggingFace spaces as a tool. So any HuggingFace space where people have created an app, you can then take advantage of and use that in your agents. So for rapid proof of concept, I can see this being really useful. Finally, what I also particularly like is their integration with MCP servers. So any public or private MCP server which hosts any tools or resources, you can link to directly. And MCP, if you're not aware of it, this is a standard that Anthropic released for sharing tools, data, and prompts. Because the way they've set things up, their code agent needs to generate code to execute tools. They've packaged in an integration with E2B, which is a way that you can execute code remotely in the cloud, which runs it in a sandbox environment to give you that security that you need if you're deploying something like this to a production setting. So for integrations, I'm going to be giving HuggingFace an 8. So next up, scalability. How well does it scale? And what I'm looking for here is two different things. The first is how well does it scale in terms of the volume and the throughput if you are using it in a production system. And the secondly is how well does it scale if you wanted to increase the complexity of the agent. And then how easy would it be to debug and manage? So firstly, how easily would it be to scale it up to a production setting? Unlike a lot of other frameworks for building agents, it doesn't support async execution. So this is a big limiting factor in making it a production system, especially when using agents. A lot of the time, your models are always going to be deployed via API calls, so the actual agent itself is not doing much except for routing and forwarding requests. For it truly to be lightweight and efficient, it needs to be async. There's also another issue with the code execution. I think it's going to be much harder to scale that. You can use a third-party service that they've suggested, E2B. However, by using that service, you've then got third-party lock-in, and if you wanted to build it yourself, it's going to be difficult and it's going to be an extra complexity that you're going to have to scale and deal with. And I don't think that's a problem for this library. I think just this library isn't really designed for heavy production use just yet, and it's also significantly newer than other libraries, so maybe they'll get there. Next up is scaling complexity. I think is also quite difficult to do. That being said, I do like the setup for their multi-agent system where you've got managed agents, which means anything that this agent doesn't know, it can delegate to its managed agents and so on and so forth down till an agent can answer the question. But the problem with that is that there's only so many managed agents you want to have here. If you with multiple nested agents, you could end up with their large round trip time, which might make it difficult to scale your complexity beyond a limited number of tools and managed agents. So for scalability, I'm going to be giving HuggingFace SmolAgents a 2. So flexibility. How does SmolAgents do at being flexible? One of the things I really like about it is that you can swap quite easily between HuggingFace models via their API, local models from HuggingFace, remote models like OpenAI, and also locally hosted models with Ollama. So they've really focused on flexibility for bringing your LLM wherever you are, which is enabled by their code agent, which means any language model can generate code. So any language model that can generate code is able to execute tool calls. Another thing I particularly like about their flexibility is you can enable planning. So you can enable additional planning steps for your language model. They do have support for a multi-agent system, and I quite like their system for designing managed agents. However, the simplicity does come at a cost. For instance, if you wanted to add a reviewing step after your tools had been executed, you could add this directly into the tool. However, by doing that, you'd then have to add the same code into every single one of your tools if you always wanted it to be executed afterwards. You would then also have to inject state into your tools using some global or class variables. And so your agents become a little bit of a black box. There's limited ways that you can change how things get executed without getting stuck into HuggingFace's code. So because of that reason, for flexibility, I'll be giving it a 6. Next up, documentation. Now, I have read all of their documentation and it is all excellent. So there's not a huge amount of it and everything there is really high quality. There's even some extra tips in this building good agents section, which I think really resonated with me, having built agents myself. It's really easy to read, it's really easy to get started with, they've got practical examples to use as well. I don't need anything else personally, and I think they've gone above and beyond to provide extra help with guidance for building agents. In addition, every page comes with its own Colab notebook, so if you want to just jump into the code, you can do. They don't have a course, but I don't think you need a course because of how simple the library is. There's not a huge amount of complexity that would warrant a course. So for documentation, I'm going to be giving HuggingFace SmolAgents a 10 because there is nothing else that I would need. Lastly, other features. It doesn't support any of the other features. It doesn't support streaming, human in the loop, time travel, memory, low code, and it only supports Python. And I can understand why. They're trying to keep it simple and not make things overly complex. Some of these things like streaming, human in the loop, and memory are things that you might want for a production system, and I think Hugging Face are positioning themselves as an open source development area. Because they haven't got them, I'm going to be giving Hugging Face SmolAgents a 0 for other features. So on to PydanticAI Agents from, you guessed it, PydanticAI. Agents in PydanticAI are the same as in SmolAgents. They are React agents, but they define agents as having these 5 characteristics. They've got to have a system prompt, tools that you provide or that you import from Pydantic, or structured output defined Pydantic. You can optionally specify any dependencies that you need to inject into your tools, and also you need to specify the language model that is. They're defined in a very similar way to SmolAgents, where you pass in the type for your dependencies that you're going to inject. And I quite like this feature, injecting building agents myself. I have had issues passing around dependencies. They use a structured output for the result, a boolean here, and the system prompt. And this is what tools look like if you define them in Pydantic. They are async by. Great, so that's how you build something that Pydantic has made core to its feature, which is not surprising given it's a framework. What this looks like in code is that you can define a model class and pass this into your agent, and then it guarantees that the output of your agent is going to be my model with a city and a. This is supported by other frameworks like LangChain, but the fact they've baked it into the agent framework just makes that a little bit easier. So do they support multi-agent? However, what they say, if an agent is like a tool, like a hammer, multi-agents are often like a sledgehammer. And let's have a look at the 3 different types of architecture they support. They support delegation, where one agent can push a task down, and this is equivalent to a sledgehammer. If you really, they support code-based, and this isn't anything they support, but just that you can string together their existing agents in code, which is also like a sledgehammer. They do also support graph-based execution, but they say that this should be an absolute last resort and that it's like a name. And to be the code example they've given for building a graph, and it is incredibly confusing. So good luck if you're going down that. Let's take a look at how each of these works. The way delegation works in Pydantic, your tool nodes can send the request on to another agent, and you can end up with this hierarchy. Tasks are pushed down the chain and then back up the chain when they've been successfully. What this looks like in code is that within one of your tools, you can then specify another agent to run with a different. One thing that isn't supported is cycles. So these you cannot implement. You can go down and back up, but if you wanted to loop from the search agent to the research agent and have some sort of feedback loop, you can't do that. You would need to use one of the other 2 approaches. I'm not going to go into the code approach, but I'll quickly go through how the graph framework works. The difference here is you can now connect your agents via a cyclic graph. So in this example, a research agent would take the task, might pass it off to a reviewer agent, which might pass it on to a coder agent to implement and run some code, which could pass it back to the research agent. And this could continue until the reviewer agent is happy with the result and the graph ends. This is one example, but in reality, this might be simpler to implement in code, and you might not need this graph-based. And as a reminder, using a graph-based framework is the equivalent of a nail gun. You might want to choose the sledgehammer or even just a standard agent first, as that will be significantly easier to debug. Great, now let's review it and see how it compares to the other frameworks. So I want to start by reviewing the learning curve for PydanticAI. So I've headed over to their documentation page and let's give it a quick review. So it's designed to make it less painful to build production-grade applications with generative AI. That's what they claim. The example that we saw a little bit earlier is very simple. You can create your agent with a single line and run it with one more line of code. So To get started, the barrier to entry is going to be really low. But on the flip side, when you get up to using a graph, if you need to, then it can get very, very complex. And it looks a bit like this. Here's an example of one of the nodes in the graph. And this is pretty difficult to digest. This is one node. You could end up with a graph with 5 to 10 nodes. And if this gets more complex, it could get very difficult to figure out what is happening, especially when you've got state in the mix as well. They've also got a different concept, which is their delegation setup. So when you're defining your tools, you can then delegate it off. Pretty big jump from going from this type of multi-agent setup to the graph-based. That being said, it is quite easy to get started. So for that reason, I'm going to be giving it a 7 for learning curve. So next up, integrations. How well does it integrate with language models, open source monitoring tools? Let's take a look. So starting with models, I think that's the most important. It integrates with OpenAI, Anthropic, Gemini, Ollama, all of the main providers, and any other OpenAI compatible models as well. It hasn't mentioned whether or not they support LangChain tools. I suspect they don't because they've got their own function decorator. The way that you provide the tools to the framework is different to LangChain. So they've tried to differentiate themselves there. So they don't support any tools that you've already previously defined like that. They don't support things like an MCP server, so that's not great. So with tools, I think they're a little bit lacking on integrations. For monitoring, they support Pydantic Logfire, which I haven't used, but this is not a language model specific logging platform, which might make it more challenging to use and debug than some other monitoring platforms like OpenLit if you're open source, or Langsmith. So because of those lack of support, I'm going to be giving it a 6 for integrations. Okay, so next up, scalability. How well does it scale in 2 different ways? How well does it scale with an increasing number of requests? And how well does it scale if you want to increase the complexity of your agent? So starting with volume scaling. They do support async execution by default, and actually you have to specify if you don't want to run it synchronously. Here's an example of what their tool calls look like. They all have to be async by default unless you specify otherwise. So async is great. They also support streaming, which means if your requirements change later in a project after you've already set up your agent, you can then enable it and just change your deployment rather than your backend. So that's really nice. I appreciate that. What's also interesting is that you can stream structured responses. So you can stream the JSON responses as they're being produced by the language model, which if you have a particularly complex data model, could be a great experience for your users seeing things appear one at a time. What I particularly like about this as well is that every intermediate response for the JSON object that's streamed is always a valid JSON object. So this will always be able to be parsed by your JSON parser. So scaling wise, I think it does a really good job. Async, streaming, but even for scaling complexity, I think it does a really good job because they've got the simpler approach, which supports the same things as a more complex graph-based approach. So it means you can start off simple and then get more complex when you need it, and you won't have to change frameworks then. So for scalability, I'm going to be giving PydanticAI a 10. On to flexibility. Based on what we just saw, the fact that you've got different levels of abstraction, you've got a very high level API and then a very low level API as well. So for me, that gives it the impression of it having a lot of flexibility. There are other frameworks that do the graph-based multi-agent programming better, like LangGraph, I believe. However, LangGraph's low-level API is not as easy to use. So I think probably PydanticAI is one of the most flexible frameworks out there that I've seen, because you can get started really quickly, but you can also scale it and make it significantly more complex. You can extend it to support streaming, it supports async out the box. So it's very flexible, so that if you start with a very simple application, you can quite happily scale that up to a complex application if you need to. So for that reason, I'm going to be giving PydanticAI a 9 for flexibility. On to documentation. So I like the fact that you can access all of their documentation from a single menu down the left. That's everything from the graph-based stuff to some practical examples and their API documentation at the bottom. I really like this, and I think it's really clean and it makes it easy to jump between various different examples to really piece together what's going on. I do find though that the documentation can be quite dense sometimes because a lot of the code examples they give are very syntax heavy. For instance, in this graph-based example, there is a lot of syntax going on with async and data class tags, which means it's very difficult to digest the logic immediately when you look at the code. That being said, explaining the graph-based applications is particularly hard, and LangGraph has had the same problems. And I think compared to SmolAgents that we looked at before, all the documentation was incredibly high quality. So I'm going to be giving Pydantic a 7 for documentation. So, other features. Starting with streaming, they do have support for streaming. They don't have direct support for human-in-the-loop execution. However, because everything is less abstract than some other frameworks, you can quite easily get stuck into the tools to just manually raise or change the flow of the code to put things in front of a human. They don't have support for memory or state persistence, and this is clearly a feature that's high in demand because when I have a look at the issues on GitHub, there are about 4 or 5 different issue requests for Pydantic to add persistence. That could be either user memory, or this could be just persistence between invocations, so that if you're having a conversation with a user and your backend is stateless, or even if you want to resume a previous conversation, then you'll need some way to persist the state easily. Because there's good support for Pydantic models, which are serializable, you could do this yourself, but it does make it a lot easier if Pydantic were to create the integrations themselves, which is what frameworks like LangGraph have done. In terms of what languages it supports, currently it's only supported in Python, and I haven't seen any low-code framework for PydanticAI. So for other features, I'll be giving Pydantic a 6. So on to LlamaIndex Workflows. How do they work? Let's take a look. A workflow in LlamaIndex is similar to a graph that we saw in Pydantic Agents and similar to a graph in LangGraph. The main difference is that it's event-based. So you still have nodes, or what they're called in LlamaIndex, steps, and the steps correspond to functions or one lot of executable fault-tolerant code. The main difference between graphs and this workflow is that this is event-driven, meaning that from the starting step, it would trigger an event asynchronously to trigger step 1. Step 1 could then trigger any number of events connecting to any number of nodes. Step 2 and 3 would then be executed together asynchronously, and then there might be 3 more nodes triggered off the back of that. And this process would continue until all events have finished being triggered, or it continually goes round in an event loop. What this produces is either intermediate streamed responses, so you could get an output from every single step if you wanted, or you could just get a final answer as a string or a Pydantic object. What this looks like in code is this. And there's not actually that many abstractions. You have to define any intermediate events that are going to be passed in between your steps. You determine where your starting step is by it's the step that takes in this start event, and it emits this custom event here. Anytime you want to pass information between steps, you have to define a new event which has its own structure. This I quite like because it means you have to be very explicit about how data and information gets passed through the network. I keep wanting to call it a graph. It is still a graph, it's just an event-driven graph. So in this instance, we have a starting step, which then goes directly to the stop event here. There is an intermediate joke event that's passed between them, but the graph stops executing when we get to the stop event. We can execute the workflow after it's instantiated with using the run method. And this is async by default, hence we need to use the await. You're also seeing here how you can pass information into the graph. So we're passing in topic here, and we're able to access it via the input event, the start event. And that's pretty much all there is to workflows. Because it is more of an orchestration framework rather than a more opinionated agentic framework, it means it's a bit more generic, and you can choose exactly what you'd like to include in the various steps in a similar way that you would with graphs in Pydantic or with graphs in LangGraph. The only thing we haven't discussed is how state is handled. What I mean by this is how you can share state between various different steps that are being executed in your event graph. And this is how it happens. You can share data between steps, and you do it with this context that you can optionally pass into your steps. From that context, you can either retrieve data or save data back. It's like a key value store, but it allows you to pass information between steps. That's how it works. Let's now see how it compares to the other frameworks. So what's the learning curve like for LlamaIndex Workflows? I think it's pretty good. They don't have a huge amount of abstractions, and I think it's fairly intuitive to understand the event flow. If we have a look at the same example that we saw a second ago, we can now see pretty much all of the abstractions you need within about 25 lines of code. The documentation is also not huge, so you can quite comfortably read all of it within half an hour, 40 minutes. That being said, because it's event-driven and all asynchronous, the learning curve for figuring out how you do things like debugging or how you integrate it into a more production system, there might be more learning there, which makes it a little bit more challenging. I think it's got an easier learning curve than Pydantic, but it's not quite as fast to get started with as HuggingFace, so I'm going to be giving it an 8 for learning curve. Okay, so integrations. Firstly, how well does it support integration with observability platforms? They've got a section here on observability. I couldn't tell if this was support for LlamaIndex or if that support extended to workflows, so I went onto their Learn page and found another page here on observability. And under third-party tools, it says that it does support any of the third-party tools that they support, such as Arise. So all of the tools under their observability here, OpenTelemetry, Arise Phoenix, OpenLit, LangFuse, any of these frameworks they've listed here, they support for observability. So that looks particularly handy. You can load and use any models that you want to within the steps of your workflow. So for instance, because you can define exactly what happens within this step, you could use OpenAI's modules or any other module that you want to use. So I'm pretty happy with integrations for LlamaIndex Workflows, and I'll be giving it a 9. So scalability, how well does it scale for both if you increase the complexity of what your agent's doing, and how well does it scale if you wanted to increase the throughput or the volume coming through your agent? So starting with complexity, because it's an event-driven framework, assuming that each of your steps is well defined, you can isolate complexity into various different parts of the framework. What I particularly like as well is that each step can then be scaled individually in terms of concurrent execution. On their learning page, I've gone to concurrent execution and emitting multiple events. You can specify the number of workers to spin up for each step, which means if one step is getting more traffic, then it can be scaled separately and independently of any of the other steps. So that's particularly useful. You can also turn on support for streaming if you need to. So with that in mind, I'm going to put it just below PydanticAI because they have particularly good tiers of abstractions, and give it a 9. So in terms of flexibility, because it is more of an orchestration framework, that immediately means you have a lot more flexibility to be able to change exactly what you define as an agent, whether that's a React agent or whether it's not. And also you can combine it with other frameworks like SmolAgents or PydanticAI to orchestrate those agents as individual steps. So that automatically means it has a lot more flexibility. If you have a task or job that needs completing that can be broken down into steps, or that you want full control over the agent to be able to complete, then this seems like a suitable framework. If it's more for a conversational agent or a co-agent, then I can see it being perhaps less suitable. You could still use it, but I think it would be less deterministic because of the event-driven setup, and harder to manage things like state. That being said, I'm going to put it on par with PydanticAI for flexibility and give it a 9. Right, in terms of documentation, they've got 2 main pages that I've found useful. They've got this workflows section in component guides, and they've also got a section under Learn, which looks like this, which gives you a good breakdown of building workflows, and this is more of a tutorial. They've also got some use cases as well, but I personally didn't find these that useful. And of course, the API reference in one place. It was quite straightforward on this main component guide page to find what I needed to know, with a convenient menu on the right. But I think what's missing for me is more of a high-level application type explanation of where workflows is applicable, what are the situations that it works well in, what it connects with, how you could use it in your situation. Instead, it kind of jumps straight into the technical details about what it is and the features it has. So I'm going to put it below the other 2 for documentation and give it a 6. Right, streaming. There's a few different types of streaming, and each type of framework claims something different. So they say here that they support streaming. However, this is more like an intermediate output from the asynchronous system rather than a true stream where you're getting every token out. So this is probably equivalent to streaming of messages in LangGraph, but it's not the equivalent of what PydanticAI does, which is streaming valid JSON for every token that's produced by the language model. It doesn't have explicit support for time travel, but you can checkpoint your workflow at any particular point if you break execution, and then you could resume it from there. In terms of memory, because you can checkpoint and save runs, that's good enough for me. You could serialize and store your inputs and outputs if you wanted to add any user configuration. They don't have any support for external memory providers like MemGPT or Letter. There's no low-code option for LlamaIndex, which I'm not really going to penalize them for because it's more of an orchestration framework rather than an agentic system. That's not really applicable here. And in terms of languages, it only supports Python. It does have support for human in the loop, explicit events that require someone to complete an action whilst the stream is ongoing. So from my list of features, it's doing better than the other two, but perhaps not as complete as the frameworks I explored in my previous video. So I'm going to be giving it a 7 for other features. So the results are in. On the left, I've got the 3 frameworks I compared in my first video, LangGraph, CrewAI and AutoGen. And on the right, I've got the 3 frameworks from this video, SmolAgents, LlamaIndex and PydanticAI. And it's still not a clear picture. I think there's a few different applications for these frameworks in a few different situations. So I now want to share with you where I believe these frameworks are going to work best. Starting with SmolAgents. SmolAgents is unique in the fact that it can work with any language model because it uses what they call code agents, generating the function calls through code rather than structured output. This means they're going to be really good for developing proof of concept, or if you're working in research, or if you need to work with smaller or open source language models. If you need an event-driven framework that's the simplest orchestrator, then I'd recommend LlamaIndex, as there's only a few different abstractions that you need to know. If you want a high-level API that's also really good for streaming, I'd be going with PydanticAI, as it supports things like dependency injection and structured output streaming. If you just want an orchestration framework, or if you're working with co-agents, conversational agents, then I would use LangGraph. And finally, if you want to use multi-agent and you've got a task-based problem to solve, and you want a high-level API, I would use CrewAI. Thanks for watching this video on agentic frameworks. Let me know your comments, or if you want to connect with me, have a look in the description below. And lastly, please like and subscribe, and I promise I'll keep making more content.